Hi, I'm Luke Kane. Welcome to Algebra 1. Today we're going to write a rational expression in lowest common terms. We've already learned how to do this in the 4th and 5th grade with numbers. Now we're going to learn how to do it with algebraic expressions. But basically it's the same idea. It's all based on a fundamental property of rational expressions. If we have P, Q, and C that are polynomials, and Q is not equal to 0 and C is not equal to 0, then P times C over Q times C is the same as P over Q. Well, that's kind of obvious because C over C, we have something, we don't know what it is, but it's divided by itself. Anything divided by itself is 1, and 1 times anything is going to be 1. So 1, of course, as you remember, is one of the two most important numbers in algebra. It's called a multiplicative identity, and here's why it's called a multiplicative identity. It reveals when I multiply P over Q by 1, I get P over Q. The other sort of idea to think about here is that the term on the left, PC over QC, those are called equivalent fractions. On the right-hand side, we have P over Q. That is the simplest form that we can express it in. We are assuming here that neither P or Q have any common factors. In math, we say that P is prime relative to Q. That is, they have no common factors. So that there are infinitely many equivalent fractions on the left-hand side that are equal to the one and only one simplest fraction. All right, let's look at a couple of examples. All right, let's go back to the 3rd grade, or maybe the 4th grade, or maybe the 5th grade. Sometime in elementary school we learned fractions, and we might have been confronted with a fraction like 4/6, and our teacher must have told us we have to simplify the terms. And basically, what does that mean? Well, we factor the numerator into 2 by 2, 2 times 2. And we factor the denominator into 3 times 2. We can split this up so that we get 2 times 3 times 2 over 2. Well, we can simplify that again. 2 over 2 is just 1. And 1 is that powerful second or maybe first most important number in algebra, the multiplicative identity. When I multiply 1 times anything, I reveal the identity of the anything. In this case, it's 2/3. Now, let's look at that in terms of our formula. Here we have P, right? Well, this is P over here. Here we have Q. Here's Q over here. Here we have C. Here we have C here. Notice that C is not 0 and Q is not 0. Here's C over here, and here's C over here. And of course, we get P over here all by itself. Get P over here all by itself. And we get Q all by itself here, and we get Q all by itself here. So basically, we've already used this formula back in elementary school. We just didn't know it. So now let's use this rule to express our rational expressions in lowest common terms. First, we're going to factor out the numerator, and then we're going to factor out the denominator completely. This is going to give us the greatest common factor. Once we get the greatest common factor, we're going to divide the numerator and the denominator by the greatest common factor, and that's going to simplify it out. Here's A. So what do we have? We have 48 t to the 7th. That's our numerator. And our denominator is 30 t squared. So let's factor them out completely. All right. 48, I can do a prime factor tree, is divisible by the lowest prime, which is 2. 2 goes into 48 24 times. Can do this again, and again, and again, and now we have all primes. And we can factor out 30. right? Same thing. Lowest prime is 2. Oops, doesn't work. 2 does not go into 30. Yes, it does. 15. 2 doesn't go into 15. It goes in 3 times. And 5. These are all primes. So, now let's do the factoring. 48 t to the 7th is going to equal 2. That 2 times that 2 times that 2 times that 2 times 3. Okay, and then the t, let's skip a space. T 1, 2, 3, 4, 5, 6, 7. Lots of t's. And 30 t squared is going to equal this 2 over here times 3. Wait a minute, let's clean this up a little. Times 3, that's this 3 over here, times 5, that's this guy over here, times t times t. Okay, now greatest common factor. Let's look for the common terms. That's a common term. That's a common term. That's a common term. And that's a common term. So we bring them down. So the GCF is going to equal 2 times 3 times t times t, which 2 times 3 is 6. T times t is just t squared. Alright, so now I have, what's my original? It's 48 t to the 7th. Alright, over 30t squared and I'm going to divide this by my greatest common factor, which is 6t squared. I'm going to divide that by my greatest common factor, which is 6t squared. 6 goes into 6 once, so I don't really need to write that down. 6 goes into 48 8 times. So that's going to equal 8. And basically I get t to the 7 minus 2. Alright? And now let's do this. 6 goes into 6 once. 6 goes into 30 5 times. So, and these two are going to cancel. So I get just 5. So this is going to equal 8. T to the 7 minus 2 is t to the 5 over 5. And that is the simplest form of this, which is an equivalent fraction. Alright, let's do this guy. B, 4m minus 12 divided by 9m minus 27. 4m minus 12 divided by 9m minus 27. And this was B. Well, we got to factor it out first. So let's factor it all out. What can I factor out of the top? Out of the top, I can factor out 2. Well, actually, I factor out 4. What am I left with? M minus 3. And from the bottom, I can factor out a 9. And what am I left with? M minus 3. Aha! Okay, well, my greatest term is m minus 3. Right? My greatest common factor is m minus 3. So, I mean, if I'm following the rules here, I'm going to divide that by m minus 3. I'm going to divide that by m minus 3. Alright, that's going to cancel that. That's going to cancel that. That's going to cancel that. And I'm left with 4 9ths. Most of the time, I'm actually going to do this in my head, though. Alright, when I get to here, I'm going to do this way. and minus 3. I know these are the same thing, so any number, whatever it is, divided by itself is 1. So that equals 4/9. All right, let's do the last one. The last one is this guy. 2z squared minus 32. 2z squared minus 32. This is C. And what's our divisor? Our divisor is this trinomial. Z squared plus 5z plus 4 over z squared plus 5z plus 4. Okay. Well, got to factor everything out. So let's factor out 2. Then I'm left with z squared minus 16. And let's factor the trinomial. Leading coefficient is 1. Hooray! That makes the first term z in both binomials. Z times z is z squared. I multiply two numbers and I get 4, and I add them together I get 5, and they're both plus. Well, that tells me this is plus, and this is plus, and factors are going to be 4 and 1. 4 times 1 is 4. 4 plus 1 is 5. That's going to work. However, I can factor this guy again. I haven't factored it completely, because this is difference of squares. So this is going to be z plus 4 over z minus 4 over z plus 4 times z plus 1. Now technically I'm going to divide these by the greatest common factor, which is z plus 4 over z plus 4. But I can see by looking at it that this and this are going to be 1. So I'm going to factor it out directly. I'm still using the same procedure technically, right? I'm still doing this. I'm dividing the numerator and the denominator, but I'm just doing it in my head. So what I end up with is 2 times the quantity z minus, not plus, z minus 4 over quantity z plus 1. Okay, so what did we learn? We learned how to use the fundamental property of rational expressions, that if we have p, q, and c as polynomials where q and c are not 0, then pc over qc is equal to p over q. In other words, we could eliminate the c over c because it's 1, and 1 times anything is anything. And we had the simple example from 6th grade that if we had a fraction 4/6, well, that's the same as 2 times 2 over 3 times 2. And that we can simplify as 2 over 3. Very basic sort of stuff. We already learned this, but we learned it in the context of simple arithmetic. Now we're learning it in the context of algebra, and it's really a simple extension. First step, we completely factor out the numerator and the denominator. So we did that in the first example, and we noticed that we have common terms, 2, 3, and t, 2 t's. So when we multiply them together, we get a greatest common factor, which is 6t squared. That's the greatest common factor of the numerator and the denominator. Well, then we divide the numerator and the denominator by the greatest common factor. When we're done, that's going to give us the simplest terms. Okay, when we're done, we are going to get 8t to the 5th over 5, because when we divided 48 divided by 6 is 8, and t to the 7th over t to the t squared is t to the 7 minus 2, which is t to the 5. T squares here completely cancel each other out, and 30 divided by 6 is 5. No big deal. Now, if you didn't really understand this, and you want to look at another examples of lowering this to lowering a rational expression of common term, you might want to look at page 449, example 3. Now, next time, we're going to take a very special case of a rational expression and simplify it. This shouldn't take long. This should probably be the shortest of the 5 videos. I'm Luke Kane. Thanks for watching. Bye now.